Hey guys, today we're going to talk about the negative exponent law or the negative exponent rule. We have so far covered the product rule, quotient rule, power rule, and zero rule. And to go over those, the product rule says when you multiply like bases, you add the exponents. The quotient rule says when you divide like bases, you subtract the exponents. The power rule states when you have double exponent or you raise a power to a power, you multiply the exponents. And then anything raised to the power of 0 is 1. So when these negative exponent law, when this negative exponent law comes in, that's the new law, is the negative exponent. Okay, so when you're using all these other laws, so the product, quotient, or power rule, and you end up with a negative exponent, we don't like that. Negative exponents are unsimplified. Remember, the name of the game is simplifying these monomials. So if you are going through using any of the other rules and your exponent becomes negative, we have to take care of that. So how you do that is you take the base. If it's in the numerator, you have to move the base that's being raised to the negative exponent to the denominator and vice versa. So if you have a negative exponent in the denominator, you move it to the numerator. Okay, so here are a couple of examples. If I have x to the power of negative 3, this is a base that's in the numerator. I know that because I can write any number or any variable that doesn't have a fraction bar as a fraction over 1. So right now, x is the base that's being raised to the power of negative 3. That base is in the numerator. It needs to get moved to the denominator. So I'm going to rewrite this as 1 over x to the power of 3. Now, I didn't flip anything. I just need to have a placeholder of 1 left in my numerator. So I took this base that has a negative exponent and I just moved it. Okay, same thing in example 2. I have 1 over x to the power of negative 2. I'm going to take the base that's being raised to the power of negative 2 in this example, and I need to move it to the numerator because it's in the denominator. So this is going to be simplified and turned into x to the power of positive 2. Now I could put over 1, but you don't have to in this case because we already know that any variable over any number by itself is already over 1. Okay, in example 3, I have x squared y to the power of negative 4 over w to the power of negative 3. So in this case, I have two bases that are being raised to a negative exponent. I have y to the power of negative 4. That's in the numerator. That's going to get moved to the denominator. And then I have w to the power of negative 3. That's in the denominator. It's got to get moved to the numerator. Now, x doesn't have a negative exponent, so I'm not going to move it. It's just going to stay where it is. So this is going to be rewritten as x to the power of 2, w to the power of positive 3 over y to the power of positive 4. So all I did was move the bases that have negative exponents, and then they become positive once they're moved. Okay, so now that we've talked about what happens if you get a negative exponent, we are going to practice putting all of these exponent rules together. So all exponent rules can be used together to simplify any monomial expression. You just have to remember the basic rules and take it step by step. There isn't really a set method for going through all of these exponent laws, but I always tell my students to go in this specific order because I really think it helps to simplify everything so you're not really missing any exponent laws as you go. So what I always like to do is use the power rule first. So step 1 is to determine whether there is a power rule. Okay, after you've applied your power rules, then you're going to go through and you are going to see, hey, am I multiplying any like bases? So that's my product rule. Or am I dividing any like bases? That's the quotient rule. So power, product, quotient. And then if you have any exponents that are negative, move them. And then that's going to be it as far as the exponents. But then also always remember, make sure your coefficients are simplified. So I think the best way to do this is to just go over a couple of examples. So let's do that. In example 1, I have x to the power of 4, y to the power of 3, times x to the power of negative 2. So first thing I want to always look for, power rule. Do I have a power rule? The answer is no, because I don't have any double exponents. So now I'm going to see if I am multiplying or I'm dividing any like bases. Well, I am multiplying like bases. I have my x's that I'm multiplying, so I'm going to go ahead and put those together and simplify them. When I multiply like bases, I add my exponents. So x to the power of 4 times x to the power of negative 2. 4 plus negative 2 is 2. So I'm left with x to the power of 2 and then y to the power of 3. I don't have any negative exponents after I applied that. I don't have any other like bases that I am multiplying or dividing, and I don't have any coefficients that I can simplify. So this is going to end up being my final answer. In example 2, I have all of the quantity x, y to the power of negative 2, all raised to the power of negative 2. So in this example, I do have a power rule that I want to use first. All of my bases, my x and my y, are being raised to the power of negative 2. So I'm going to go ahead and multiply those exponents together. X has an exponent of 1. So 1 times negative 2 is negative 2. And then y to the power of negative 2 raised to the power of negative 2 is y to the power of 4. So I've applied my power rule. Now I'm going to check. Do I have any quotient or product rule I can apply? I do not. All of my bases are combined. So now what I'm going to do is check. Do I have any negative exponents? I do have a negative exponent here. X is being raised to the power of negative 2. It's in the numerator, so I need to move it to the denominator. Remember, this is now over 1. So the x is going to get moved to the bottom. So this is going to become y to the power of 4. That's going to stay in the numerator because it doesn't have a negative exponent. And then in the denominator, I'm going to have x to the power of 2. So now I'm going to look. I don't have any other product or quotient rule I missed. None of my exponents are negative, and I don't have any coefficients I can simplify. So this is going to end up being my final answer. Okay, in example 3, I have x to the power of 2 over x to the power of 4. I don't have a power rule, so I have a quotient rule, and I'm going to apply that first. X to the power of 2 over x to the power of 4, 2 minus 4. So this is going to end up being x to the power of negative 2. My exponent is negative, so I have to move that. So I'm left with 1 over x to the power of 2. I don't have any like bases I can combine, and I don't have any coefficients I need to simplify. So this is going to end up being my final answer. Okay, in example 4, I have 2x to the power of 4 over x to the power of negative 2. So I don't have a power rule, but I do have a quotient rule. I'm dividing like bases of x's. Those are being divided. So here, this is going to turn into 2 to the power of x to the 4 minus negative 2, which is 6. Looking at my simplified monomial now, I don't have any negative exponents. I don't have any like bases that I am dividing or multiplying, and I don't have any coefficients that I can simplify, so this is going to end up being my final answer. Okay, in example 5, last one, I have 2x to the power of negative 2 over y to the power of 2, all raised to the power of negative 3. So this is a really big power rule first. So I'm going to take every single base that's being raised to the power of negative 3, and I'm going to multiply their exponents. Remember, the coefficient of 2, has an exponent of 1. So this is going to end up equaling 2 to the power of negative 3, because 1 times negative 3 is negative 3. X to the power of negative 2 times negative 3 is positive 6, over y to the power of negative 6. Okay, so I applied my power rule. I don't have a product or a quotient rule. I don't have any like bases I can divide or multiply, but I do have some negative exponents, so I'm going to take care of those first. My first one I see is 2 to the power of negative 3. That's going to get moved to the denominator. And then I also have a y to the power of negative 6. That's going to get moved to my numerator. So this is going to equal x to the power of 6. That didn't move. Y to the power of 6, that became positive once I moved it, over 2 to the power of positive 3. So I don't have any more negative exponents, but I do have a coefficient I can simplify. So this is going to end up being x to the power of 6, y to the power of 6, over 2 cubed, which is 8. There are no more like bases, and nothing's negative, so this is going to end up being my final answer.